Hi, everyone, and welcome to Spotlight with Scientists in School. Today, I am joined by astrophysicist, book author, science communicator, Dr. Parshati Patel. Welcome to the show.
Thank you for having me.
This is really a treat. I can't wait to get into it all. Stars, planets, space, it's just so exciting. But let's start like I always do right at the beginning. Were you a curious child?
I was. I think I used to ask too many questions. And my parents, I come from an era we didn't have internet until probably like end of high school. So they just bought me a lot of books. And the more books I got, I think the more curious I became. It wasn't just science or space. I remember last time going back home and I used to have books on history and geography and, like all of these different things. It wasn't just science, which I'm surprised that, I used to read other things as well.
Right. It wasn't just science. You can be curious about other things. Did you have an encyclopedia set? You mentioned days before the internet.
A lot of them. Apparently also like very thick dictionaries for some reason too. So I was really surprised last time the whatever leftover books I got to see, my mom donated a lot of those books, but she had some and I had a reverse dictionary and I'm like, I don't know why I had it, but it's interesting that we used to have these books that, didn't only entail about the facts, we were also looking at so many different things.
Yeah, how interesting. Now, you mentioned a little bit back home. Where was back home and what brought you to Canada?
Yeah, so I grew up in India. I'm from Ahmedabad, Gujarat, and I was born and brought up there. I did my, elementary and high school there, and I even did 2 years of bachelor's in physics in India. And I realized early on that I wanted to study astronomy, and I talked to a lot of scientists that were there while I was in high school, and a lot of them suggested that move abroad and try and see if you want to do this at bachelor's level, because you never know, after you try out something you may not like it. And so I always was fascinated with space and I really loved the idea of studying it, but I got this idea from them that it's much more than just reading facts. It involves a lot more when it comes to research, so you may want to try it from bachelor. So I decided that I wanted to go abroad. I did not know which country, so I was looked at US. I got into schools, but I couldn't get the visa, so I was like, okay, where else can I go? I had like Canada, Australia, and then I picked Canada, and I'm so glad I did, because I absolutely love the fact that I love the country and people here, and that's how I ended up here.
And shoveling the snow, because I'm sure you had to shovel snow today. That was okay.
I did not think about that when I was selecting Canada.
Yeah, exactly. So you're in Canada, you're still studying planets, stars, you have your doctorate. I've noticed that you prefer to call yourself an astrophysicist over an astronomer. Why is that?
There are actually a couple of reasons for that. One is the experience that I've had when you tell people you're an astronomer, and this is primarily kind of from back home, where astronomy and astrology is generally mixed up very easily. And so when I used to tell people astronomy, people would think I'm an astrologer and they would ask me for like,
I'm
like,
reading.
Yeah, exactly. I've had so many of those. And so I was like, but when I say I'm an astrophysicist, you get a different reaction, because people then automatically say, oh, physics, oh, that's science, like they automatically attach you to science. And so I decided to try this thing where, like, instead of saying I'm an astronomer, I would say astrophysicist, and people had a different reaction. And I realized that people were more intrigued when I say astrophysicist, because it's like a mystery. It's like, what is an astrophysicist, right? And so I started using that, and technically I am an astrophysicist. So if you look at it, I studied stars, so a stellar astrophysicist. I used computer models, so I'm a computational astrophysicist. I use physics to do all of that. So it's very close to the technical term that we use. And so I feel like, it's better to tell people what exactly you're doing and to bring them to the depths of things, rather than just, leaving this vague idea of what, astronomy obviously entails a lot more than just, studying stars and being an astrophysicist. So.
Okay, so let's talk a little bit about stars and planets, because we have kids watching as well. And at Scientists in School, we're so excited. We just launched a new virtual workshop called Our Place in Space. So it's fantastic that we have you on board. So we're going to start with the basics. What makes a star a star? What makes a planet a planet?
Yeah, that's a great way to start, because we have our sun, which is a star, but why is it not a planet? It's a ball of gas, and kind of in the simplest terms as we can tell. It's around from the gravity. It's producing a lot of heat and light. That's something that planets don't do. They may have some residual heat that is coming out from the time they formed, but they don't produce the light and the energy, the amount that a star does. So basically a star is a ball of gas that is producing a lot of light and energy, and it's round because of the gravity. Now planets, given that we have discovered so many, not only in our solar system, different types of objects, but then beyond as well, we kind of have a distinct definition for the planets now. So first of all, it needs to be round, like a sphere, because of the gravity. It also needs to be, large enough to have cleared its neighborhood. What I mean by that is, people might think, oh, this is why we don't call Pluto a planet anymore, is because around Pluto, there are other objects that are almost half its size or as big. And when you clear your orbit around the sun and you are the biggest object in that orbit, you can call yourself a planet. And so that's the major distinction between star planets and dwarf planets.
See, I grew up in the time where Pluto was a planet.
Me
still,
too.
Right?
Me
yes.
too.
I remember that day when all of a sudden, no, it's not considered a planet anymore. Okay, so we'll get to planets in a second. I just wanted to know, are stars the brightest thing in our solar system?
So our sun is the brightest in our solar system. If you go further beyond, obviously there are many more stars, in the universe. There are different kinds of objects that are much more brighter than our sun. So we're lucky, we're close to the sun. We have sun as the brightest object in our sky, but as you go beyond, the sun is not the brightest star. There are different kinds of stars, and there's some that I studied that are like one of the most biggest stars, and they're much more brighter and much more bigger as well.
Okay, now in the early 1990s, it's unbelievable that we really thought we only knew of the planets in our solar system. I kind of find that mind-boggling, right? And now we know that there's many more. So my first question is, are we talking thousands, millions, billions? How many more are there?
So we have detected, or we should say discovered, 4,908 as of February 2nd. And I'm being very specific because
I'm surprised. I'm surprised you gave a specific number, to be honest. Yeah, okay.
Yeah, the reason is because, every day that number changes, because as we have more tools and more technology to be sifting through the data and looking for more and more planets around other stars. These are called exoplanets. And so that number is increasing and it changes, couple of months ago, if I would have said it would probably like 4,800, now it's 4,900, next month it might be different. That's just because of the amount of observations we're taking and we're going through. And the most interesting part about these is these, 4,900 of them that we have found aren't just like, a star and a planet. A lot of them, actually more than 3,600 of them, are actually in multiple, in a solar system that has multiple planets. So it's kind of like ours in some ways, but not to the extent of what we have. So it's very interesting to see that we have found so many of them just by looking at a very small patch for a very, very small time. So, just by the statistics or kind of the data that we have, if we look at, our galaxy, we think there are more planets in our galaxy than there are stars in our galaxy. And that is it just blows your mind when you think about that.
It does. It does. So let me ask you the next thing. So in the 90s, we only knew of these planets. What changed that now we know that there's so much more? What changed with our technology, obviously, but can you give me more specifics?
So we have, many more different methods we're using now to detect these planets, but we also have, as you said, more technology. We have dedicated telescopes that particularly, literally their job is to look for these kinds of planets. And then we also have many more people kind of working in that direction as well and sifting through that data that we have collected over years. Interestingly, I said there are 4,900 planets we have found, but just using the data that we have collected so far, we think there are at least 8,400 more that we call them candidates. So, they've been detected by one telescope, but we always, look for other ways to make sure that they're confirmed. So we use different techniques to confirm them. And so we still have these 8,400 that we haven't even confirmed, and so there are a lot more ways to now look out. There are a lot more different technologies. People are using multiple of them to not only detect and confirm them. And there are newer technologies coming out as well. And I think one of the ones that I would like to highlight, specifically here in Canada, we have just launched the James Webb Space Telescope, and that telescope, will also be looking at these exoplanets. So there are a lot more, things that are available for astronomers to look for these exoplanets.
Now, these 4,900 planets, do they all have names? Are they all given names or just numbers, or what happens there?
Yeah, so it's a very there's a unique way of numbering them. I think in our solar system we have like Earth, Mars, all of these different names. But when you're using different telescopes to detect these, first of all, these planets get named after their star. So for example, let's say we have Proxima Centauri, it's the closest star, and there is a planet around it. The one that was found is Proxima Centauri B. So, we just have like a little b. Sometimes you get numbers based on the, there's a Kepler 61, Kepler 361, like there are lots of different numbers that we give to the stars. And then based on that, each of the planet get these little alphabets next to them based on the discovery. So it's a very interesting way of naming them, but also it's more for astronomers to look at it from the data wise rather than having a very interesting name for all of these. I mean, there are going to be hundreds and thousands of them being discovered every year. It would be weird to just like start to find names to name each of them.
Yeah. Is there a planet that's equally habitable as Earth, do you think, out there?
Definitely. I think, we have found so many planets that are in what we call the habitable zone. So this is a zone in which, if you were to put liquid water, it's far away from its star, that the water would be liquid. And we know, like, here on Earth, we are basing everything that we know about life here on Earth. And we're trying to look for planets that look similar to Earth. So one of the systems I would want to name, there are tons of these habitable planets out there. And obviously, as we get to know more of them, that catalog changes. But the one system that is very interesting that I would like to mention is the TRAPPIST-1 system. And it's very interesting because it has, these 7 planets. It's a small star. It's not as big as our sun. But from the observations, it looks like they're all rocky planets, and they could all potentially have some kind of water on it. Some of them, fitting in that habitable zone and could have liquid water. So, and it's only 40 light years away. So if we can find a way to travel at the speed of light, it would only take us 40 years to get there.
Only 40 light years away. So what makes a planet habitable? Bring it down to the basics. What would it need so that, we could live there? What are you looking for?
Yeah, so something that we look for is definitely, having water, because, that is very important for life. Having, temperature that would be something that is not too extreme. And this is why we call the habitable zone, because you don't want the extremes. You also want to make sure that there is some kind of land. We look for things kind of very similar to Earth in many ways, because really this is our only example of life in the universe, and we're taking whatever we can from here and trying to find planets that look or feel similar in that way. So I think water is the most crucial one, just because we know that, even if it's just water planet, like literally ocean, you could still possibly have life there. And so we look for things that are looking very similar to Earth.
I'm sure you find so many things fascinating. There are, I've got them listed here, black holes, nebulas, neutron stars. Do you have a favorite? Is it or something that you love to look at or follow?
My interest in space came from stars and planets. And I think that has to do with the fact that we could look up and see them and know that they exist. And everything else, I've like, when I was young, I just felt like this is too far-fetched. I don't understand a lot of the stuff. But as I studied, I still was really intrigued by star forming regions. So these are nebulas where the stars forms. It's like stellar nurseries, basically. And then I was always fascinated by young stars. And, these stars, so like our sun, when it was like a baby, like a toddler, other stars that are more massive, what are the phases that they go through? And especially the stars that I studied, and the reason why I picked those stars to study was because they form behind a wall of gas and dust. You cannot really see them from here. And, the one really strange thing about astronomy is you cannot go to your specimen that you're trying to study. So all you have is light. And so trying to decode that behind this thick wall of dust and gas, I find them really like mysterious. And like, I always get curious to know more about what's happening there. So young stars and star forming regions are like my favorite things to look at, but also to like to study as well.
So, Parshati, we're going to switch gears because you're not only an astrophysicist, but you've really gotten into the world of outreach and science communication. You are the co-founder of Women of Color in STEAM, and that's with 2 M's, so science, technology, engineering, arts, math, and medicine. Tell me, how can we work together to ensure that youth, girls, and women of color consider this field?
Yeah, it's something that is dear to my heart just because of my experience and, the culture that I come from. I did not have role models as I was growing up. Even though I wanted to go into the field of astronomy, my role model was Dr. Kalpana Chawla. She was a NASA astronaut. But I didn't want to be an astronaut. I wanted to be an astrophysicist. But the fact that what she was able to do, being, someone who looked like me, coming from the similar culture, I took it as, if she could do it, I could do it. So really, I think one of the things, and thanks to you guys are also bringing a lot of these role models that kids today need, because if they don't see themselves there, they won't be able to follow their role model's path and be able to be there. And then for people like us who are already in the field, I think one of the things that I always think about is bringing other people on to that table, bringing the opportunities to them, giving them the voice, amplifying their voice, and helping them get where they want to get. And so I think there are 2 ways to do that: giving them role models, but also showing them that it is okay to not know where you want to go. You can explore these different areas. And, I switched fields from astrophysics to science communication and education after my PhD. So like, right. You can always find your passion at a certain point in life, and you find a role model and you go towards it. And if it doesn't work out for you, don't feel like it, you change it. So, being open to that vulnerability of people's, idea of where they want to go, I think is also very important, because I always find people, trying to sway people in one direction or the other. And I think it's important to show them where you could go rather than forcing them to go in a certain direction. And it works for all different fields, whether it's, STEM or STEAM or, STEAM with double M's, does not matter. In whatever field you want to go, you just need to make sure that you open doors for people wherever you go.
Truer words could not have been spoken. Thank you for that. That's wonderful. Parshati, you do something else too. You're not only, I keep saying, astrophysicist, science communicator extraordinaire, but you've always wanted to write a book, and your dream was realized. And I showed you before I pressed record that I actually went out and got this book, my book of Stars and Planets, a fact-filled guide to space. This is amazing. How did this come to be?
This is very interesting. I always, and well, I wouldn't say always, because it was only a few years ago when I went back to India that someone asked me, like, when are you writing a book? Because I would love to show my parents that someone from our community could do the science, because they were in engineering and they wanted to go into sciences. And I was like, oh, I never thought about writing a book. And so my first idea was like, oh, maybe I should write about a book for young kids, just having a character that goes through kind of the similar life phase that I went through while trying to venture into a field that is not normal for people. And that was my first idea, but I hadn't really worked on it or anything. I just had this idea. And then DK reached out to me, and I read a lot of DK books as I was growing up. And so I was like, I think it's a very common thing for everyone to have that in their house. And so when they reached out to me, they found my video on YouTube, and they saw, and they asked if I would be interested in writing. And I was like, this is not the kind of book I was thinking of writing at first, but it's DK. Like, I read this book, I got inspired, I got excited, and I passed it on to my nieces and nephews. Now I need to, like, maybe I can give back, it's, move out that idea of actually writing a children's book that is about a character, it goes through life, but actually talk about the facts that I find so interesting. And when they reached out, they're like, it's going to be a book about facts, and here are the topics we want to cover. And I got so excited because I wanted to write so much more, but there's only so much you can fill in those boxes, right? So I decided that it is my time to give back from what I got when I was young. And I said yes. I was just like, I cannot pass up this opportunity. It was a very stressful time because I was starting, a new job, and also trying to do this. And it's not easy. Actually, the whole book was written within a few months. So
oh, really?
Yeah, it's a 96-page book, and so it's a lot of work and within 3 or 4 months try to finish. But I think I really enjoyed the process, just trying to figure out which facts are more interesting than the others.
There's great facts. First of all, it's full of pictures. It's really great, but you do have a lot of great facts. Like, I just loved reading simple things like on the moon, there's a place called the Sea of Tranquility, but there's no water on it, right? Those are good conversations to have with your kids. I also loved, at what point do you become an astronaut? Like, we all fly in airplanes, but then there's that, I think it was 100K, and then you're considered an astronaut. So it's filled with a lot of great facts.
And exactly what I wanted to do was give little nuggets of things that can inspire more, that curiosity, and be like, oh, I want to know more about it. Now let's go and look it up,
Exactly.
And that's exactly what this book does. It covers so many different topics, and it's literally just like space. It goes from engineering to astronomy to stars to galaxies, everything you can think of.
Yeah. And like I said, it's those little nuggets, right? So someone might read something about the telescopes and say, oh, I want to learn more. And it's like, boom, let's go figure it out. Yeah, it's great.
Exactly.
You're also diving into photography. You want to take great pictures. Do you have a tip on how to take a great photo of the night sky?
Yeah, definitely. It's one of my passions that has grown during the pandemic, obviously, being at home. One of the things, you can use your cell phone or whatever camera you have. Cell phones are actually very intelligent nowadays. They all have a night mode. You want to prop it up on a tripod, or even, on books or rock, and just make sure it's steady and expose it for at least, 5 to 10 seconds. And you can get amazing pictures just with your cell phone. And then, I've had my friends experience that first time getting that 10-second exposure on a rock, and they cannot believe their phones can do that nowadays. So, I would suggest everyone to try it out at least once. Just maybe right now, find Orion in the night sky and point it, leave it for 10 seconds and see what you get.
Dr. Patel, this was so interesting. I'm sure anybody watching would be inspired to look up at the sky and get to know space. And I love the title of our workshop, Our Place in Space. There's a lot to think about. It's just wonderful. So thank you so much. Thank you.
Thank you for having me.